Welcome back to our channel. In previous video we discussed what is single linked list and what are the operations performed on single linked list. Now in this video we are going to discuss how to implement or how to write the code for single linked list. See, single linked list, a node consisting of just, I will give you brief introduction. I will recollect the things. For example, this is single linked list. Last node's next pointer is null and 10, the data elements, 10, 20, 30 are the data elements. Then addresses, suppose 100, 200, 200. Here the address is 300. Here the address is null. A header node is a node. This is called as what? Header node. Header node. What is a header node? Header node stores an address of first node. An address of first node. So, here first node address is 100. That's why here it will store 100 and the data value present here it is garbage. What is this one? This is garbage value. Okay. So now how to perform operations? So insertion operation, if you want to perform like this. This is suppose header node and the data elements. For example, if this is the case, only two data elements are there, 10, 20, and this is your head node. Suppose this is 100, this is 200, this may be 500. So here the value is present 100 and here it is 200. Now I want to insert in between these two. So like this we will insert now. So 80. So like this we are going to perform insertion operation. So now how we are going to create a list? This is already existing list. This is list is already existing list. In this we are going to perform insertion operation. But now how can we create a list? Create a list. Here list is nothing but a single linked list. How to create a list? So now initially this is header node. Header node's next node is null. So now one by one we will insert. This is garbage value. One by one we will insert. We will insert that new node as the last node. Okay. This is 10. Then our SLL is, this is garbage and this is the node 10. Next, same garbage. So now I want to insert another element. This is the list. Now I want to insert another element 20 like this. Then what will happen? Like this the elements are inserted. Then the list is, this is head node, garbage. Here it is 10 and here it is 20. Like that a new node is created at the end. See, here new node is created. Initially list is empty. New node is added. New node is added at the end. Similarly, this node 20 is added at the end. At the end we have inserted. Okay, so now we are going to implement this in C language. So how to implement in C language? The node structure is this one now. So this is data partition and it is a next pointer. So we will use the concept of structures in C. Structures in C. What is a structure? Structure is a collection of heterogeneous data elements. Heterogeneous data elements. Structure means collection of heterogeneous data elements that we will store in a single variable is called as a structure. Now we are going to implement this SLL program. How to create a single linked list, that we will discuss. Okay, let us go to implementation now. So this is implementation of single linked list. Okay, just I will save single ll dot c. Okay, just I will open that file, whatever now I have created. Single, this one, yeah. So now here, now what I said, first we had to create a structure of a node that I am writing in comments. Structure of a node. So we will include first header files, hash include stdio.h, next hash include conio.h. So now structure of a node. Structure of a node. How we will define structure of a node? Struct node. So first partition is data partition and the next partition is pointer to the next node. So struct node star next. Okay, so what is this called as? This is called as self-referential structure. This is called as self-referential structure. Now, so structure definition is completed. Now, I will save this program once. So now we have to create single linked list. How to create single linked list? By adding it the new node. And I am declaring one node like a head node, star head, and another one is a star ptr. So now we will create one by one. We will create a list. Create. So in each node we have to insert data na. So that is element. So now here we will initialize a ptr to head node, and one new node we have to create. So we will declare struct node star, struct node star new node. We are inserting new node na, so new node. For that new node memory allocation should be there. So that's why we will allocate memory using my malloc function. So I am writing in comments allocating memory dynamically for what? For the new node. So by using which function? Malloc function. So in malloc, by using malloc we will allocate the memory. How to allocate the memory? New node equal to struct node star. See, the function here it is malloc. See this malloc function in C language you will get that one. In malloc function returns void pointer actually. That's why here we have to typecast. We have typecasted with struct node star, as a node is a pointer. That's why struct node star. How much memory do you want to allocate? That we don't know. That's why size of. So what is how many bytes of memory we have to allocate? So that's why here struct node we have given. So memory is allocated for the new node. So then what shall we do? We have to create the links between this node and this node. Now if you observe, see, this is a head node na? This head node, this link we have to give. This link we have to give. See, this link. This link we have to give. How can we give this link? Okay. Now, how can we give that link? New node of, actually first we will insert data, ELE, then new node of, always we are adding at the end, so that's why null. Then ptr of next equal to null, and you are adding always at the end, no, so that's why we have to move pointer to the last node, moving pointer to the last node. How to move pointer to the last node? So while ptr of next until last node is nothing but null pointer, next partition is null pointer, so ptr of next not equal to null. Until then what we have to do, we have to move pointer to the next node, ptr equal to ptr of next. Okay, then inserting data and giving ptr of next equal to new node. So like that we have created the list. So after creation we have to display, otherwise we don't know whether the list is created or not. So that's why we are displaying the list by using the function display function. So in the display function, see, we will ptr here in create function we are moving pointer, na? Here we are moving pointer to the end. We are displaying from the beginning. We are displaying a node from the beginning. That means pointer should move to the first position. So that's why here ptr is initialized to head node. So again, while, so you have to print from first node to last node. So that's why here until last node, ptr of next not equal to null. Then we have to print the data, na? So printf %d/t ptr of next of data. Why? Because see, why I am writing ptr's next of data. So if you observe, see here it is a head node and here it is a ptr. Okay, then this you can refer as ptr's next. So in this ptr's next of data means 10. So that's why in the program we have written ptr's next of data. So then move pointer to the next node, ptr equal to ptr of next. Close your display function. Now save it once. Yeah. Now void main. So we will initialize the head of. Initially head of next, no nodes are present, na? That's why head node's next position is null pointer. We are initializing. Okay. Then always ptr is present at head node initially. Okay. So head node. Now we will create the list. First we will insert 10, then we will insert 20, then we will insert 30. After insertion we will try to display. If it displays correctly, then your list is created correctly. Okay. Now simply here I will print a message. Printf the SLL is colon double quotes close. That's it. Now we will save this one once. Compile. So we are getting errors. Declaration syntax error. See, declaration syntax error. Spelling struct. See, don't worry if you are getting any errors. So if you are getting errors while doing the program, then if you are able to rectify the errors, then you will get programming language. So then you can know what you must not do while writing the program. That you can learn. So that's why don't worry whenever you are getting errors. So try to rectify them. See. So next, see, if you missed that spelling, you are getting 12 errors. If you modified that to correct keyword, see, there are no errors. So don't worry. So whenever you are getting number of errors, so just to rectify them. Even though if you are getting 25 errors, just you rectified only one mistake, then all 25 errors will be removed. That's why don't count so these many number of errors you are getting. Don't fear. So try to rectify them. Next, compile the program. Now execute. See, the SLL is 10, 20, 30. Yeah, list is created. Okay. So now in our program, now see, now list is created. Now we have the list. Like this, you have the list. This is head node. So how we have created? 10. This is the list. 10. This is 20. And this is 30. So this is head node. PTR is always present here. We don't bother about the data partition. Like this list we have created. Now we will perform the operations. Insertion operation we will perform. Okay. So how can we perform insertion operation as we discussed previously? So like this. This is your PTR. Move pointer to the required position. So this is new node. New node's next equal to PTR's next, and PTR's next equal to new node, and new node's data equal to 15. Like that you can perform insertion operation. So we will add that insertion function here itself. Okay. Right. So created the list, then now we will insert. So void insert of which element you want to insert and in which position you want to insert. Which position you want to insert. Okay. Like this. Now again we are inserting new node na. So struct new node we had to declare star new node. Struct node star new node. Okay, and we have to move pointer to the required position. That's why we are initializing. Then we will move pointer to the required position. Move pointer to the required position. What is the meaning of required position? The meaning of required position is here. See, this is position number 1. This is position number 1. This is position number 2. Position number 3. I want to insert a new element in third position. That means we have to move up to which position? Second position. That means if POS equal to 3, then you have to move pointer up to which position? We have to move pointer up to POS -1 position only. So we will write that logic here. While PTR of next not equal to null and I less than POS, move pointer to the next node. PTR equal to PTR of next, and I should be incremented for finding position. So we moved pointer to the required position. So now allocate memory for the new node. So how can we allocate? That we have done already in the create method. The same you can write. New node equal to struct node star malloc size of struct node. Okay, allocated memory dynamically. Then giving pointers. How we are giving pointers? See the diagram. So if you observe the diagram, how we are going to insert? This is new node. This is new nodes next. So new nodes next equal to what? PTRs next. New nodes next equal to PTRs next. Then what is PTRs next? PTRs next equal to new node. Now, here we will write like new node of, first we will insert a data element, then new node of next equal to PTR of next, then PTR of next equal to new node. That's it. Save your program. Insert function. Now, after creating and displaying, now insert of, I want to insert 100 in second position. After insertion, again we have to call display. Whether that list is created correctly or not, that we can know if you display the elements. That's why after insertion again we have to call the function display function. Now save the program. Now here I will write one message printf after insertion. Otherwise we may not understand. After insertion the SLL is. That's it. Save, compile, execute. See here I will give you clear screen. I will give CLR SCR. Okay, compile, execute. See first 10, 20, 30. Then after insertion SLL is. In which position we want to insert? What is the position we have given? In second position we are given, but it is initialized in last position. Na? So here what shall we do? See, PTR we had to initialize. We forgot that one. So PTR always should present at the beginning. So we missed that one. Now compile. Error. Okay. So after declaration only we have to write the logical statements. So after this declaration I will write PTR equal to. So PTR is moving back to its first position. Yes. Compile. Then execute. Run the program. See, initially the list is 10, 20, 30. After that we have inserted 100 in second position. So the list is 10, 100, 20, 30. That's it. We have inserted the element in the given position. This is insertion operation. Hope you understand the students. If you like this video, please like, share and subscribe the channel. And if you have any doubts, you can post your query in the comment box. Thank you. Have a great day. Bye.